Say you are having two domain, C1 and C2. Okay, Z0 is interior to both C1 and C2. So can I say that integral over C1 f of z, whatever it is, that will be equal to integral over f of z over C2? Do you observe this thing? Really, f of z upon z minus z0 upon z minus z0, because z0 is my interior point, and I just want to use Cauchy integral formula. Do you observe this thing, this pattern? If my C1 and C2 having that Z0 is inside that, say something Z0 is here, say this is my C1 and you can take this is my C2, correct? Both have Z0 as their interior, so their integral will be same. Do you observe, हम लोगों ने इतने क्वेश्चन सॉल्व किया, you will see that if I am giving the same interior point, then answer भी same आएगा. You just go back and check each and every thing, you will get to know. When you are having same interior point, or I can quickly give you one simple example. I'll just quickly give you one simple example. Say uh, z into e raised to z upon z minus 1 dz, where c1 say uh, where c1 is this, that is say mod z less than 1, less than equal to 1. I want to include that one also. C2 is equal to say mod z is less than equal to 3. Suppose you are having this. So can you tell me what is this integral over C1? That is z e raised to z upon z minus 1. Can I use my Cauchy integral formula? Because Cauchy integral formula says that if 1 is interior to C1 and z minus 1 is in denominator, then what? The answer will be 2 pi I f of 1. F of 1, it means 1 into e raised to 1. So answer is 2 pi I e. Okay, what if I am putting over C2? Then again you have to see the same thing. Do you agree? That is whether 1 is interior to Z2. Yes, mod Z less than 3 बोला है, तो 1 is interior to that, and so again the same thing, answer will be 2 pi I, and it will be f of 1, that is 1 into e raised to 1. So answer is 2 pi I e. In both the cases these are same. So with this logic we'll be saying something. We'll be actually let us see the proof. That was just a hint. Let us see the proof of Cauchy integral formula. If you forgot about the statement, then just I may write it like again. फिर से लिखूं या कहाँ पे लिखूं? और मैंने लिखा है क्या? यहाँ पे है. I think it is on the next slide. Previous one. Okay. The same condition जो भी extended Cauchy में था, सेम थिंग, बस यहाँ पे फॉर्मूला चेंज है. दैट इज इट इज़ फॉर n इज इक्वल टू 0. यहाँ पे n 0 पुट करो, जो भी आंसर है दैट इज. सो एफ बी एनालिटिक एवरीवेयर इनसाइड एंड ऑन अ सिंपली क्लोज कंटूर C taken in the positive sense. If z0 is a point interior to C, then if you see something like this integral, then answer will be this. This is this is the statement, correct? I'm not going to prove extended Cauchy. I'm just telling you Cauchy integral, and I'll just give you a hint how will you prove the extended Cauchy integral. Okay, yeah, let us start. So we begin the proof of the theorem by letting C rho, I'm giving one more guys, C rho, that denote positively oriented circle, that is say mod z minus z not equal to rho. Okay, where rho is small enough that 0 is interior to C. Interior to C. That means what? Suppose this is your C, correct? And there you get your Z naught. So we need to have a C row. We need to decide a row such that I can get a circle. I'm sorry. That I'll say as C row, and that is completely lying inside C, and we can get that correct because I can choose row as small as I want, and if my domain is like this, then also I can get a circle around that point, so I can get this 0. Do you agree? Okay, now again the same logic जो मैंने बताया, z naught is interior, and this is my 0 and over this c. So what can I say? That integral f of z upon z minus z naught over c will be same as integral f of z upon z naught over c rho. Actually this is called principle of deformation of path. So you can write, since the quotient f of z upon z minus z naught is analytic between and on the contours 0 and C. It follows the principle of deformation, principle of deformation of paths, that means that is integral f of z dz upon z minus z naught, that will be equal to integral f of z dz upon z minus z naught. This is over C, and it will be equal to over 0. Correct? So once you get this, correct? So let us do one more thing. Can I consider this part? Suppose I just keep it. I just want to put one equation one बोलो तभी भी चलेगा, or you just write like this. That is integral f of z. Suppose if I take yeah, okay, integral f of z dz upon z minus z naught minus f of z naught minus f of z naught, or if you want to write like, you may write like this. Just derivative हम लोग जैसे लिखते हैं, dz. Can I write like this? इसको अलग कर सकता हूँ. That is integral. See, f of z naught is constant for me, so it will be integral f of z minus z naught dz minus, you can take f of z naught outside, it will be integral 1 upon z minus z naught dz over this 0, over this 0, correct? Over this 0. Can I do that? Integral over this 0, it will be equal to this and this, but this guy is same as over C. So in the next line I'll be writing this as over C, and I can find this 1 upon z minus z naught over 0. See, this is a constant function, तो इसका integral क्या आएगा? Can you quickly tell me? It doesn't depend on function. Can you do that? You are having parameters. You don't have to use Cauchy integral, ना, क्योंकि प्रूफ वही करने जा रहा है और तुम Cauchy integral ही यूज करोगे, तो that is not a good thing. You should use parameterization. क्या use करोगे? You are already given. What is my rho? ये c rho क्या है? Your c rho is this mod z minus z naught equal to rho. So what parameterization you will choose? Put z equal to z naught plus rho e raised to I theta. You substitute karo and that's it. Derivative लो, you will see that you'll get the answer easily. It will be something 2 pi I and something. It will be 2 pi I actually. Even I think मैंने मतलब start में कराया भी होगा ये वाला part. If you use this as a substitution, okay? So let me just write it. Okay, so let us keep this as it is. So I'm having over 0 f of z minus f of z naught upon z minus z naught dz. That is equal to what? This is same as 0 is same as over c. So this will be over c f of z upon z minus z naught. Do you see हम लोग का जो प्रूफ करना है उसका लेफ्ट हैंड साइड इज दिस गाय and this is minus what is this f of z naught multiply by what is 1 upon z minus z naught. If you still did not get that कि solve कैसे करना है तो बताओ, I can do that for you. Use the substitution or maybe I'll do that. I'll write it here 1 upon z minus z naught dz over 0. Let us do this quickly to solve. Oh, okay. Now you what I want to solve? I want to solve this part. That is integral 1 upon z minus z naught 0. Integral 1 upon z minus z naught 0 dz. Okay, you need to substitute what is 0? Where 0 is z minus z naught equal to rho. So let us use the parameterization. Z minus z naught equal to rho e raised to I theta. What is dz? Dz will be it will be rho I e raised to I theta, correct? And d theta. This is what you are having. Now let us try to solve. क्या आएगा substitute करेंगे तो this will become 0 to 2 pi and this will be dz का value क्या आएगा rho I e raised to I theta and नीचे z minus z naught का value क्या आएगा rho e raised to I theta d theta, correct? So ये गया I'll be having I 2 pi I. Do you agree? That is I'll be getting 2 pi I. So this was one part. Let us come back to the this again. So इसका वैल्यू मिल गया मेरे को क्या 2 pi I. That is f of z minus f of z naught upon z minus z naught. That is equal to integral f of z upon z minus z naught dz over c minus it will be 2 pi I f of z naught because f of z naught was multiplied, correct? F of z naught into a, so it will be f of z naught into 2 pi. And do you observe the Cauchy integral फॉर्मूला होता है वो क्या होता है this is equal to this, मतलब मुझे प्रूफ करना है ये जो बंदा है that is 0. if you prove this then we are done actually कि ये जो part है that is 0 for me then I am done. This is equal to this, that is my Cauchy integral formula. So how will you prove this thing is 0? That is the required part. How will you prove? अभी तक हम लोगों ने एक पार्ट नहीं यूज़ किया सिंस फंक्शन इज एनालिटिक, सो वो कंटिन्यूस भी रहेगा इवन डिफरेंशिएबल एंड मेनी थिंग. सो कैन आई यूज in calculus you if you want to prove two things are equal then it is better to prove their subtraction is less than some epsilon for every epsilon, correct? If you are able to do that then we are done. That is this is equal to this. That means if you want to prove this so consideration part लिखता हूँ मैं. After leaving some space let us do consider I want to prove this, that is integral f of z dz upon z minus z naught minus 2 pi I f of z naught. This is what I want to prove कि ये दोनों equal है, correct? But this thing is same as what? Integral over cp 0 f of z minus f of z naught upon z minus z naught dz, correct? Okay. Yeah, so can I do next something? This will be less than equal to mod of that, एंड इवन एम एल इनइक्वालिटी हम लोग ने बताया था, इनइक्वालिटी के बारे में बात किया था कि जब भी ऐसा कुछ हो तो दिस विल बी बाउंड फॉर दिस मल्टीप्लाई बाय वन अपॉन दैट, सो दिस विल बी लेस देन, और लेट मी have the bound first. This will be less than equal to 1 upon 0 f of z minus f of z naught upon z minus z naught dz, correct? Now have you seen f of z minus z naught somewhere? Yes, it is the definition of continuity. Can I use the definition of continuity? Since f is analytic, so implies f is continuous at z naught. What is the definition of continuity? For all epsilon positive, there exists delta such that mod of z minus z naught less than delta. This should imply what? Mod of f of z minus f of z naught, that should be less than epsilon, correct? Now we need to make sure that let the radius rho of the circle 0 be smaller than the number sigma in the second of this inequality. That is less than the number sigma. See, I already told you ये रो हम लोग decide कर सकते हैं. We can take row as small as I want. I just need to get this row smaller than this sigma. Z minus Z not less than sigma. एक continuity का definition use करने पे जो आता है sigma, उससे छोटा रहना चाहिए. That's it. Okay. So what will I get then if I'm having this? Then I'll be getting this as this will be epsilon. This will be epsilon and mod of z minus z naught, that is rho. Sorry, mod will be on this also. So it will be epsilon upon rho, and that will be ये दोनों गए तो integral it will be 2 pi I, that is it. 2 pi I. It will be just arc length, that is circumference, 2 pi rho, correct? So this is what I am having. Rho cancel karo, I am having what? 2 pi epsilon, and that is also a constant. So did I prove that this guy will be less than this? That means what? This is equal to this, because it is true for any epsilon, correct? You may write if you want. Since the left hand side of this inequality is a non-negative constant, okay, that is less than what? That is less than an arbitrary small positive number, so it must be 0. Left hand side must be 0. Hence what will you get? That is integral f of z upon z minus z naught dz, that will be equal to what? 2 pi I f of z naught. Hence proof over C. Hence proved, correct? I'll just quickly repeat. Our first logic was over C. हम लोग को पहले C रो चाहिए था because we are good with circles. कि circles के साथ we can play easily. So I could see that this is equal to this. So I started with 0, ये क्या आएगा ये, and I subtracted that. F of z naught is constant and this is equal to 2 pi I, which I showed you here by solving here, correct? So this is what I am getting, f of z over 0, f of z minus f of z naught over 0, this is equal to this. Now if you observe that Cauchy integral formula क्या होता है, this equal to this, मतलब I need to prove this guy is less than 0. And in calculus, if you want to prove something is 0, sorry, not less than, so if you want to prove something is 0, then take their subtraction and prove that is less than any epsilon, for any epsilon or arbitrary any epsilon, correct? So this is what my logic was. So I got to see, I consider here, consider ye over 0, and I got to see that this is equal to this. No, this is okay. This is c over c. The next step here over 0, and if we use mod inequality, this will be less than equal to mod of this, mod of this. Mod of z minus z naught is rho. Mod of f of z minus f of z naught is epsilon by, since function is analytic, so continuous भी रहेगा, so continuity का definition लगाया, that's it. And yeah, that's it. So we are having this is this equal to this. So this is your Cauchy integral formula. We have proved the Cauchy integral formula. Now to prove extension of Cauchy integral. What is extension of Cauchy integral? That is f of z upon z minus z naught raised to n plus 1 dz, that is equal to क्या था, 2 pi I f nth derivative at z naught upon n factorial, that is extension. You can write corollary, extension of Cauchy integral, correct? So let us do it for 2, for n equal to, that is for this. So उसके लिए मुझे क्या करना रहेगा, जो भी फंक्शन मिला है, ट्राई टू ऑब्जर्व एफ nth डेरिवेटिव क्या है. फ्रॉम हियर ट्राई टू सी एफ ऑफ जेड नॉट का वैल्यू मिला तुमको ये, करेक्ट? एंड इफ यू वांट टू टेक द डेरिवेटिव ऑफ दैट, तो मुझे मिलना चाहिए नेक्स्ट गाय, दैट इज आई वांट हियर स्क्वायर, z माइनस जेड नॉट का स्क्वायर यहाँ पे चाहिए, एंड यहाँ पे क्या आएगा, एफ डैश आ जाएगा, करेक्ट? सो लेट अस यूज दैट लॉजिक एंड डू इट फॉर n इक्वल टू 1 2 3 सबके लिए होएगा, फिर हो जाएगा. 1 के लिए हम लोग ने किया है, let us try to do it, try to prove it for 2. Actually n equal to 1, let us prove for n equal to 1. that means क्या रहेगा ये, that is integral f of z upon z minus z naught the whole square dz, that is equal to 2 pi I f dash of z naught upon n factorial. Okay, that is what you want to prove. F dash of z naught is equal to what, over C, that is f dash of z naught equal to n factorial upon 2 pi I and integral f of z upon z minus z naught the whole square. I'll just give you a simple hint. तुमको f of z naught का वैल्यू पता है, you already know what is f of z naught, correct? So let me write pi Cauchy integral formula. What do you know what is f of z naught? f of z naught equal to क्या आएगा ये देखो, that is integral f of z upon z minus z naught dz, and what is this, 1 upon 2 pi I. So this is what you are having, 1 upon 2 pi I. f of z naught का वैल्यू पता है, can I find derivative? You know how to find the derivative of a function, correct? So it is as simple as that. You want to find the derivative, then you should use the डेरिवेटिव का फर्स्ट प्रिंसिपल का फॉर्मूला, फंक्शन का वैल्यू दिया है, एंड इट इज़ इजी टू डू दैट, करेक्ट? So I just give this as exercise for you. Do the by first principle. try to prove by first principle of derivative. डेरिवेटिव का फॉर्मूला अप्लाई करो, यू विल सी कि बहुत सिंपल है, वो कुछ है नहीं इसमें, ठीक। नहीं हुआ तो विल डू इट लेटर ऑन, बट आई जस्ट वांट यू टू ट्राई फर्स्ट. Okay. Now let us do some consequences of this extension. Okay. The first theorem. If a function is analytic at a given point, then its derivative of all orders are analytic there too. Analytic there too. And how is it possible? If you see by the definition of Cauchy integral formula, you can get all the derivative of z naught. ये देखो, you see, हम लोगों ने सिर्फ z naught का analyticity देख के, that is z naught was my interior point. I proved this extension. We proved this extension का formula by using this f of value, by using adding f of z naught. I proved everything. Where is that extension वाला page? It got deleted, I think. Okay. So what is that? That is integral f of z upon z minus z naught raised to n plus 1 dz, that is equal to 2 pi I f nth derivative upon n factorial. Do you see first derivative, so I can get nth derivative of that. So this is what the theorem says. If a function is analytic at a given point, then its derivative of all orders are analytic too. And you know how can you write that, correct? First derivative, second derivative, third derivative, everything you can write it. Or even if you go with this f of z equal to say u plus iv लिया, so f dash of z क्या आएगा? It will be ux plus ivx, correct? And what is f double dash of z? वो क्या आएगा? uxx plus ivxx and so on, correct? So this was the first consequence. Second, say corollary to that, if a function f of z, say u plus iv, same u is function of x and y, v is also function of x and y, is analytic at a point z equal to x comma y या x plus i by बोलो, then the component function u and v have continuous partial derivative of all orders at that point, correct? And that is as simple as that. See, from Cauchy integral, from extension Cauchy integral हम लोग को मिला कि nth derivative is possible. अगर वो nth time differentiable है, so that means I can write it like this: f dash मिलेगा, f double dash मिलेगा, and everything ux, uxx, vxx, and Cauchy integral, or what is that called? Cauchy-Riemann equation. By using Cauchy-Riemann equation, I can get Ex equal to Vy, Uy equal to minus. So I can get all the partial derivatives. They are continuous and of all the order, whatever order 2, order 3, whatever it takes, it will be. Right? Okay. So this was easy. Now the next theorem is theorem 2. That is Moreira theorem बोलते हैं इसको. Moreira theorem or Moreira's, that is converse of Cauchy-Goursat theorem. You can say this is converse of Cauchy-Goursat theorem. If I say, write it, then you'll see that correct. See, let f be continuous let f be continuous on a domain D if integral f of z dz over c equal to 0 for every closed contour to C in D, then f is analytic throughout D. Correct? Do you see how beautiful this theorem is? If your integral is 0, then the function is analytic. And इसका हम लोग ने Cauchy-Goursat theorem क्या किया था? If my function is analytic in D, then integral over that function is 0. Correct? अगर function analytic है throughout your D, then the integral will be 0. Now we are doing the converse of that. Okay, and that is again possible by using extension. Analytic मतलब क्या? It should have continuous partial derivative of all order. It is infinitely many time differentiable. Correct? And by extension you already see कि first derivative, second derivative all depends on your this guy. Nth derivative all depends on this guy only. You remember this? This is called converse of Cauchy-Goursat theorem. You can say Moreira theorem. The writer is Moreira for this, for the proof. Next, one more theorem is that, and that we have already seen. हम लोग ने Cauchy इंटीग्रल को लेकर दिया था. Now let us see extension. Suppose that a function f is analytic inside and on a positively oriented circle CR centered at Z0 and with radius R. If MR denote the maximum value of f of z mod f of z on CR, then that is f nth derivative at Z0 that is less than equal to n factorial mr upon r raised to n. हम लोग ने ये सब किसके लिए किया था? आई थिंक n इक्वल टू वन के लिए किया था. We had done this for n equal to 1, f first derivative this, and this is possible by using that same extension का formula क्या है? What is your nth derivative? Recall f nth derivative at z not equal to what? N factorial upon 2 pi I. and f of z dz upon z minus z naught raised to n plus 1, correct. Mod लिया तो it will be mod under this and that will be mr, and ये just you can solve that. It will be something 2 pi r, and ये नीचे क्या आएगा, r raised to n plus 1 आएगा, यहाँ पे m आ जाएगा, and that will be 2 pi I. So 2 pi I get cancelled, and you'll be having n factorial m upon r raised to n, correct. Yeah, and 2 pi r आएगा, so 1 r will get cancelled. That is easy. If you want I can do it for you. That is mod of f nth of z naught, that is less than equal to what, n factorial upon क्या है 2 pi I and integral of mod, that is f of z upon z minus z naught raised to n plus 1 dz. So next step में ये क्या आएगा, this will be just like this, n factorial upon 2 pi I r raised to n, and this will be m, and this will be just integral over that cr है, तो आंसर क्या आएगा इसका, it will be, जिसको हम लोग ने एम आर डिनोट किया शायद, it depends on your r. So this will be n factorial upon 2 pi I r raised to n plus 1, I'm sorry, this will be n plus 1 because this is mod z minus z raised to n plus 1. So this will be r raised to n plus 1, here it will be multiplied by, here mr is already there, and iska perimeter that is 2 pi r. So r get cancel, 2 pi get cancel, and I'm missing something. I, yeah, mod लिया तो I will also get punished. 0 to 2 pi r in factorial. I'm sorry, actually I तो mod लिया तो I तो आएगा ही नहीं पहले में. So it will be f nth derivative at z naught, mod will be less than equal to, because I, if you are included, that means it is a complex number ना. So inequality को complex number से थोड़ी less than कर सकते, and mod लिया तो it will be a real number definitely. This is less than equal to n factorial upon what, upon it is mr r raised to n, correct. 2 pi get cancel, r get cancel, and this is what you are having. Yes, correct. So that was the thing.